Howdy, Beeflowbart here, and welcome. You have to pardon me, I'm a little bit run down this evening. I know that's nothing new, right? But anyway, we'll try to get things done on the first video, and then I will move on to another video later. And let's get into it. Now, trying to come up with more features to add. This is my build map. By the way, it's good whenever you're setting up a project to have a map that you can just set up for testing things, like a test map, a test build map. This is one where I'll actually construct things. See, I actually have the third-person character in here. I haven't bothered converting him over to the Cindy Studios assets, because you're not going to see that in the main bulk of the game anyway. Maybe, maybe not. But later on, yes. Right now, no. So it wasn't really a big issue to convert him over to the Cindy asset. Kept looking at the idea of adding new gadgets in, and we've got the let's actually go to the test track really quickly, and with that we set up the lap feature, the checkpoint feature, some kind of fail saves to be able to prevent people from cheating. As you can see, added a speed strip in. Also added in a little simple feature. Whenever you go to handbrake, your taillights come on. Really stupid simple. I'll show you how I made that. There's so many different ways you can actually make that effect work, but I did it the easy way. The speed strip will actually boost your speed, and if you try to go back on it the wrong direction, to the I changed it where it says wrong way stupid on the the checkpoints, so you can't go back across it the wrong direction. So you actually have to be going in the correct direction to be able to get it to work. And even if you hit it the wrong way, it's still going to push it. So the effect, you can thank Dean Ashford for doing a video on the moving conveyor system, and essentially it's his model and material that's being used for it. So you can see, even if I'm moving at a lower speed, it just picks me right up and throws me at that higher speed. Now, the only change I did to the car's dynamics was, this is kind of looks like a Camaro, so I kept it to where it was more true to the original and is rear-wheel drive instead of all-wheel drive. The default car system is set to four-wheel drive and limited slip differential. So I changed that over to two-wheel drive, or rear-wheel drive with limited slip differential, which is something that a muscle car might have. It would not be four-wheel drive. Although I have seen an all-wheel drive Camaro like this, and it was freaking badass. I prefer all-wheel drive on a vehicle myself, but it's because my daily driver is all-wheel drive and has a V8 engine and all that cool stuff. So I had start-finish to that as well, and if you look at it from this direction, it says wrong way stupid. And we still have our interior view. So the speed strip and the change to the car. Let's look at the car first. In the car, to add the taillights, essentially all I added was two lights, regular point lights, and whenever you look at them, left brake light and right brake light, I made sure that I unchecked visible, so they're not visible by default. And on the brake lights, so that they're replicated and work in multiplayer. Essentially all I did was created client brake light on custom event, and it was run as multicast. And then I brought in the left and right brake lights, and all I'm doing is, whenever I'm turning on the brake lights, I'm turning the visibility to on for both the left and right brake. Now, I didn't need to put both of them on here. I could have just connected both lines to there. I left it this way to be kind of more visible, but you can actually connect the left and the right to the same one and actually delete this, so you don't need a second piece in there. So let's actually delete both of them, and at this point, left brake light and right brake light can now be joined to the same node that's using the other one right here. And let's compile and save and show that it does still work. And all you can see is the client. You can see it still works. And if I go over here to the server, which is on a different monitor, you can see it works as well. And change that back to 1. So, doing that, I just condensed it a little bit. Just because my OCD will make sure that I have to do this. Alright, so that's what the client side does for turning them on and off. And then we run server brake light on, which tells the system to switch as authority. And this is a run on server for replicates. And the same thing for server brake lights off. And then I ran a custom event saying brake light on and brake light off. So for each one of them, it just refers back to the server event. And from there, you had to have a keybind, which was already in the handbrake output, or input rather. And all I did was added some more room and put in the custom events for brake light on and brake light off, because the original was this right here. So all I did was add those custom events for brake light on and off to right there. And that's how I did the brake light system. Really simple, really easy, and it works. And it replicates. For the speed strip, let's go back to the build map. When you place the piece itself into the map, and this is built as per the Dean Ashford tutorial. Don't know why it sinks down still. But then whenever you place it in the map, you walk over to it. The arrows are kind of giving you an idea of which direction it's actually going. So you can stand on it and it moves you along. Let's actually take it and zero it out. And we're going to scale it up. You can use your scaling tools. Now, if you watch what happens to the arrows, so we'll scale it by 5 and by 2. And let's grab my player start and just move it closer so we're not walking 5 miles to get to it. So you can see the arrow speed changes based on the scale of everything. And you could place them next to each other, and you could actually rotate this one a different direction, and so you can connect them to go in different directions. You just have to be mindful, using the way that he did it, that your material or your actual meshes are not overlapping, because what can actually happen is it'll try to push the other one if you put it too close. But it's kind of boring if it's all just the same speed. And this will work for any object that actually goes on here, not just a player or a character. But with the way it's set up, and his video actually shows how to do everything, you can actually adjust the speed. Let's double that to 500. Change the color. So it's moving a little faster now. You can see the arrows don't match with the speed of it. So you can actually change the scale of the arrows. Change that to 3. You can change the track speed to -0.1 or just -1. If you do it in the positive, then and that could have probably been set up in the material setup, so that you don't have to put the number in the negative. It just multiplies the number or whatever, and creates it as a negative no matter what. So you can adjust the speeds of it. I mean, you can crank up the speed really high if you want to, and adjust the speed of everything. So the fun part of that is when you set that into your map, especially for vehicle, and I can just go into my world settings, change my game mode over to vehicle game mode, hit play. You see, it changes your speed while you're on that, but it does not change your speed whenever you get off of it. One of the things that I found while screwing with this was, let's change it to 2500. And I'll show you what I'm talking about here is, since it speeds you up while you're on there and not when you're off, you go back to a normal speed once you get off of it. So if you were to take this and actually change the rotation of it so that it's like a ramp, I had kind of high hopes for this. Like, well, hell, I'll just make this into a ramp, and when I drive onto it with my car, it's just going to throw me off into the air and make really cool super jumps, and it doesn't. So I'll look see if there's something I can do to fix that issue. You can see it powers me up, but I just immediately just fall right off the edge. And same thing if I go back to third-person game mode. If I walk over to it, it stops me right there at the edge, and it doesn't propel me forward. So, I don't know if there's anything I can do that will affect that. Well, let's take a look at the blueprint. It runs off of the event tick, and it uses some of the construction script as well. And in the viewport, you can see all we have is an arrow component, which, I could move that arrow component if I want to. And nothing is actually calling it. It's just an idea to know that you're putting it down in the correct direction if the moving material wasn't enough to let you know. But in the event graph, essentially off the event tick, you're creating a couple variables, which speed, color, arrow scales, track speed. His video does a really good job of explaining what everything does on it. I've just tried to neaten it up a little bit. We can see this is all there is in the event graph. So an event tick is multiplying the delta seconds, because if you run an event tick, it's running off of your FPS. Coffee. So if you're getting 120 frames per second, then that's how often it's going to run this event. And so you take your basic frame rate and you multiply it by the speed, which default speed is 250, and that's going to get combined with your conveyor static mesh. It gets a world rotation, gets the forward vector, and then you're multiplying that by the speed set by the event tick, multiplied by your speed default. Also getting a reference to your box collision. You're getting overlapping actors, and now with this right here, if you only want this to affect characters or players, then you, instead of get overlapping actors, you can change that perhaps to something else like event, the overlap event. So since this is actually doing it that way, if you did not want, let's say if you knocked a traffic cone in there, and the traffic cone has collision events and all that stuff set up on it in physics, if you don't want those to actually move down that conveyor system, then you can actually change this and this and this. And so instead of using those three pieces, you can actually instead use the right click on component begin overlap and use a cast to character reference and try get pawn owner and use that instead. So if you only want characters to be affected by that, which would probably not be a bad idea. The construction script is where it's actually referring to the material and the speed of the material as it's moving through, and I'll show you the actual material here in just a second. But it's getting the conveyor static mesh, it's creating a dynamic material instance for this in slot element 01. If we look at the static mesh, it actually has two. You've got the red, which is the frame, and that's a material I added. And then the actual moving element is in element 0. So the default automatically is element 0. So when you're creating that dynamic material instance, you're going to then set the material to the material created here and the actual moving material name here. So it's also setting it based off of the vector parameter value. Again, his video does a really good job of showing how to do it, and using color here, which is, and I'll show you in the material, and X scale and X speed. So that's pretty much it on this. I would say if you really want to learn how to do this and make that moving strip like that, then I would definitely go and watch his video. He does a much better job of explaining it than I will. In the material itself, you see we're setting up the scalar parameters and the appendment to it. So we got X scale, speed, and Y speed. Your texture sample, your color, and everything all boils down to is we're plumbing all this into the emissive color. Again, his video does a really good job of covering that. So I'm not going to get too in depth. But that's that on that. Like I said, I will look at some other ways of setting it up to where you see the box collision doesn't go all the way to the end, so you can actually, and it slightly hovers over the top because, and there is no material. He made the actual piece, the static mesh itself, and did not put a material on the bottom. So there's no way for me to add one to that unless I combine it with another static mesh or whatever else, but not a big deal because for what I'm doing, it just needed to be on the track. Go back to the test track. So for a car game, there's a lot of different things that need to go into it. I still haven't changed over the meshes for the track itself, and I will be replacing that with City Studios road pieces. But for the car itself, an important thing. When you go into the vehicle movement, you've got under the differential setup, the differential type, limited slip rear drive. You see you've got limited slip four-wheel drive, front drive, rear drive, open differential four-wheel drive, open front, and open rear. If you're not familiar with what an open versus a limited slip differential is, you shouldn't be making a car game. Just kidding. Limited slip means it's going to allow one tire to slip a little bit whenever it's putting power to the wheels. Whenever you're talking about a rear-wheel drive vehicle, engine, transmission, drive shaft, axle, and then in the axle it goes into a couple gears and it splits it off to the left and the right side. But what can happen is, and what does happen, if you have, say, a locked differential where it's giving equal power to left and right hand side all the time, when you're turning your vehicle, say if you're making a left hand turn, the left-hand wheel is turning less revolutions than the right-hand side tire is making that left-hand turn, because the left wheel has to travel farther in the arc of that circle than the left-hand side does. So what happens is it allows the left-hand tire or left-hand side to actually slip a little bit, so that you're getting more power to the right side, so that because it's traveling more. If not, then it's going to cause your left-hand side to bind a little bit. And what happens with, say, my vehicle? It's an all-wheel drive, and it's got a powerful 360 cubic inch V8 motor and all this cool stuff. But what happens is if I make a tight turn with that vehicle, you'll actually hear the tires spinning. If I'm making a left-hand turn, the left-hand tires are going to spin a little bit because they're still getting a lot of that power, and the axles are kind of binding a little bit in a tight turn, and you'll actually hear what sounds like I'm spinning the tires as I'm making a sharp turn. And it's because it's the application of the power. But if it was a completely open differential system, then the left-hand tire would then just not be getting any traction. It's going to be like electricity. It's going to take the path of least resistance. So it's still trying to put the power to that left-hand tire, so therefore it's binding and chirping and making all kind of noise. An open differential, what can happen is if you're off-road, as a prime example, and you're twisting up the axles, you're on some really off-camber terrain, and one tire now is floating in the air. The other tire on that axle is touching ground. With an open differential, the saddest part is it's going to go path of least resistance, and now that tire that's hanging in the air is getting all the power, and the one that you need to have power, which is on the frickin' ground, is getting no power because it's got more resistance. So it's allowing the tire that doesn't need the traction to get all the traction. It's absolutely stupid. I've gotten stuck before because of having in four-wheel drive, the one tire on the front axle on the ground, one in the air, rear axle, one tire on the ground and one tire in the air. And so therefore, the two tires, one in the front, one in the back, that are on the ground were getting no traction whatsoever because the two tires that are in the air are getting all the damn traction. So I'm therefore stuck, and I had to have somebody come over and stand on my back bumper to force both tires on the back axle to now get traction so that I could move forward and unbind the front axle, and then being able to continue on. I hope that made a little bit of sense, but muscle cars, hot rods, most street cars are going to be either a limited slip or open rear wheel drive. A lot of modern cars are going to be either open front drive or limited slip front drive, with exceptions of cars like my Jeep Grand Cherokee 5.9 Limited, or the new Trackhawk, or there's some other cars that are actually all-wheel drive. In that case, you could do limited slip 4-wheel or open 4-wheel. So if you're trying to create a car that's all-wheel drive, then I would select either limited slip 4W or open 4W for trying to create that car correctly. Now, you can do a front and rear split. It's set at 0.45. If you're doing four-wheel drive system, then you can use this to actually create that split. If you want the front to get more power than the rear, then you can adjust this scalar. And it kind of gives you an explanation of that. You can do the same thing on the rear, although I would leave both of these the same so that the left and right sides are getting equal. So 0.5 is going to be in the middle. So both tires on the left and right hand side are going to get the same amount of power. You got center bias, front bias, and rear bias. You can change all these different things for your limited slip. So experiment with them and try to scale them to get them about where you want. But with a game that I'm targeting towards, I'm going to want to be able to add new tires or add improvements to the engine, a turbo or a supercharger or nitrous or whatever else. And I'm going to need to be able to affect things, but the only time you would ever affect anything on the differential setup would be to changing your tires, or which there's also things you can change in the tires, because when you're setting up that your vehicle blueprints, where are you? Vehicle blueprints, sedan. Okay, so you got your front and your rear. So as you look at the wheel, the collision mesh, I wouldn't mess with that. It's a cylinder. It's what it needs to be. You can start changing things like your offset. So it can change your offset of your wheel position, the shape radius. I haven't figured out the actual units versus real yet, but that's something you would have to think of. If you want a larger diameter tire or a smaller diameter tire, that can be kind of accomplished with this. The width of the tire, the mass, how much it actually weighs. So if you're generating a lot of power, you might want a little bit more mass on that wheel so that it can help with that. Damping rate would be kind of like your shock absorber damping rate. Whether or not it's affected by a handbrake, and this is the rear, so you definitely want it affected by the handbrake. Steering angle, if you're trying to set up four-wheel steering, that's something you could affect by doing this. How much it'll actually turn. Your stiffness values, suspension values here. So if you're trying to get stiffer suspension, then you're going to want to mess with these values here. And as I start adding in the parts portion of this, being able to change to another piece here. What I have not done, and I'll experiment really quickly here, but that's the differential. You got the engine setup. Your max RPM is actually going to affect your top speed. So if we just change this out to 6,000, just to kind of round it up a little bit, what's going to happen is we're going to get a slightly higher top speed now. Still contending with the fact that all of our power is coming from the rear. So now we have just slightly improved top speed. But your damping rate and other things that you can adjust here, but adjusting them here, I want to adjust them in the blueprint. I want to be able to, my respawn system there, create a system of variables to check the parts. Maybe pull from a structure, because with structures, for example, in the track generator, they're using a structure here, and you're getting the pullable stuff that you can pull in here, like whether it's going to use the left guardrail, right guardrail, the bank, width, and thickness. You can put all kinds of different variables into one structure and be able to call to them and pull them, and I've showed how to use them in another video as well. But I want to be able to have a part system established to where if I add a supercharger or a turbocharger, then I want to affect the overall performance of the engine. You also have transmission data. You can change the gear ratios. The final ratio 4.0 is actually kind of common for front-wheel drive cars. I know that like the Honda CRX that I used to drag race had a final drive of 4.1. But you can actually Google this information. It'll help get you in the right direction. Clutch strength, reverse gear ratio. What's quite common here is gear 1 is going to be steep. It's 4 to 1, 2 to 1. To go to third gear, it's 1.5 to 1. Fourth gear, 1.1 to 1. Fifth gear, which is 1.0 to 1. And if you had an overdrive, it would then go to under 1.0. So it would be like 0.7 or 0.8 or something like that for an overdrive. And see, this is set for automatic transmission. I have never tried to set up a manual transmission or shifting for the transmission. That's something that I'll have to look into for people who actually want to shift gears. But how do you get this information here? Your engine setup, max RPM, MOI is moment of inertia. And mousing over, you get a basic idea of what each one is. Damping rate. Let's say for a max RPM, if you add a turbo on, or if you want to add a turbo boost, let's say you can increase this number for a short term from 6,000 to 8,000. So what would happen? We just got a reference to this, and since what we're looking for is engine setup, all right, so get engine rotation speed. What we're looking for is max RPM. So let's look for RPM. Nothing. Get max speed. Get engine max rotation speed, which I guess that would be the same. And I guess what I can try to do is print that to a text value. And all I'll do is just for now, doesn't matter what I'm doing unless this is not going to stay. So we're just going to print that, and I don't think I've got any. Yeah, I do have event tick right here, and we'll just do right there under the event tick, and hopefully that will show up something. So it's just showing the max value right there. So it is showing that it is 6,000. That's the number that we manually gave to it. So that's fine. It's just getting that max value. So I guess if we wanted to actually make amendments to that, then we could do a key binding, and with that key binding, if we hit the spacebar key, we're wanting to give it more max speed because we're giving it that turbo boost. It's just allowing for a top speed or whatever else. So that's something to look at. But at least we're able to define that value. And that's the thing, is being able to grab these values and manipulate them is something that's going to be very important. If you're wanting to set up a four-wheel drive game, and let's see if we can come up with differential type. Nothing. Yeah, DIF. I don't see any direct. Get modified max speed, vehicle movement. I don't see anything in here so far. Yeah, just difference. I don't see anything for differential setup. And would be nice to be able to switch between two-wheel drive and four-wheel drive. Interesting. No. Nothing for a limited slip. Nothing for differential. No idea. I'm going to have to look at that and see if I can come up with something for that. If you guys come up with suggestions and things you'd like to see in this project, let me know. I'm kind of working on feature stuff first. So let's get rid of that and that. And I'll spend some time trying to come up with ways of fixing that. And in the second video for the evening, what I'll do is, once I figure out how to get that to work, so that I can change the limited slip to four-wheel drive, we'll say. So instead of rear-wheel drive, we can change it to all-wheel drive or four-wheel drive. I will see what it takes to actually be able to use this in the actual blueprint and manipulate that. Other things you can look at is steering setup, and you can change the steering curve based off of, I'm assuming that's the speed, but there's your wheel setups, depreciated spring. Yeah, there's a lot of different things you can actually mess with. Like, here's your mass. You can change the mass. I'm assuming that's the mass of your vehicle. So you can change that to increase it to make the car a little bit heavier, or lower to be a little bit lighter. Reverse as brake, which that means if you're hitting the S key, or whatever, the normal reverse key will actually stop the car first and then allow you to start going backwards. That's actually kind of common. But I'll see what it takes to actually be able to call all these pieces here from the vehicle movement, to be able to call them into the blueprint so they can be modified. And that's something that's going to be very important, because we're going to want to be able to modify these settings as we're adding parts. So we can say that this turbo adds X number of horsepower, or top speed, or acceleration, or be able to change the values of what that actual part does. Change to a supercharger, or a turbo, or a new intake manifold, or if you're changing your shock absorbers, or your sway bars, or all these different parts you can change on a vehicle that will affect the overall performance. I need to be able to do that within a blueprint environment so that I can actually change those parameters. So I'll have a way of setting up, this is what this does. And as I figure it out, I'll let you guys know. But also, jump on the Discord channel, UE4 general channel, and just say, hey, what about this for a car game? And yeah, just jump in and do it. If you want to join in on this project, let me know. I'm going to go ahead and finish off this video. I've got some things I need to take care of really quickly, family stuff, and as I figure out these other things, I will bring up a new stream and show you what I'm doing with them, and how I'm manipulating them, and how I'm setting up the part structure of how to be able to get them into and usable in game. Alright guys and gals, thanks for watching, and we'll see you soon.